Okay, so today's learning target is I can understand the importance of slope and how it affects the linear patterns. So here is kind of a skill check for all of you. These are the different skills that we have learned this far uh, in this class. If you are still having trouble with any of them, please make sure that you ask for help. Review, your different practices as well as the slides. All right, so here is a quick practice of how do we even put together a mathematical and science equation. So we are going to use the linear pattern equation as an example. So here are all the different variables for you. What is the mathematical equation? So what I need to do is I need to take this equation and I need to plug in the x and the y, or the x, not the x, the a and the b. So y equals a, which is 10, x plus b, which is the 2. So remember that the math equation uses x and y. So all I did was I got rid of a and b. And now when I move towards the science equation, I'm going to get rid of the x and the y, and I'm going to use the variables. So y is distance, and then the 10 is going to be carried down from up here down here. The x is time, so it's multiplied by time, plus 2. And so I replaced x and y with the different variables. Okay, so that is how you get from the math equation to the science equation. Here's just a reminder of the poster, just in case you need it. And then our assignment today is trying to make sense of slope. So slope is the rate of change on a linear line, is the rise over run. And in science, slope represents something in the real world. So it's not just a random number, it actually has a meaning to it. Really quickly before I show you the assignment, on Monday, we are going to have a quiz on the linear pattern and understanding slope. So please take your time over the weekend to review and see where you might still be a little confused. So this is the assignment, and it's on Google Classroom. Just really quick, this challenge portions are always optional. It's how you get from a 4 to a 5, or you attempt to get to a 5. There's no guarantees that you'll get a 5. Depends on your understanding, and over time, hopefully you can get to that 5 level. All right, so let's start at the top. So this is a linear line. I didn't place it on here, so just for a quick reminder for all of us, the linear math equation is y equals ax plus b. So what I need to do is I need to find the science model for the spring system, and this is for the purple spring, which is this line right here. So I know that my a is 2 because it is right here. So I am just really quickly going to put it into the math model because it makes it easier once I have A and B figured out to replace X and Y. So B is your y-intercept. Remember, the y-intercept is where does it hit on the y-axis. So all 3 of these lines have a B of 0 because they all come from the origin. So my B is 0. Once I get this, all I need to do is replace the X and the Y. So here's the y-axis right here. So the y is length. I can just go in and type length equals 2 times my mass, because that is my x, okay, plus 0. That's how I found my science model. To get to my, or to figure out what the length is at 1 kilogram, so this is the mass, because it says 1 kilogram of mass. All I need to do is take the 1 and plug it into the equation. So what I can do is I can copy this down. All right, so I know this is 1 kilogram. And 2 times 1 is 2, plus 0 is still 2. So my length is 2 meters. So I know these units because it is marked on the graph as well. Again, what will the length be if we add 2 kilograms of mass? So I can again, oh, I already copied it, so I'm just going to re-paste it down here. And now instead of 1, I'm going to put in 2. 2 times 2 is 4, plus 0 is still 4. So my answer is 4 meters. Why does the difference in length needed between 1 kilogram and 2 kilogram make sense according to the science model for the spring? Hint, refer to the poster on the wall. So you don't have a poster on the wall, but this is the poster that it's talking about. And it's talking about this part right here where it's explaining when X doubles, Y doubles. So I already left the answer in here. When mass doubles, length doubles.